Hi guys, welcome to my YouTube channel. So in the video today we will learn about the basics of PyTorch. Now PyTorch is one of the backbone of deep learning, considering it is one of the most popular packages which are used to create multiple deep learning algorithms. Along with TensorFlow, they are the only two known packages for deep learning applications. PyTorch is considered to be slightly more flexible than TensorFlow, and that is the reason it is gaining more popularity in the recent 3 4 years. And one thing, just to highlight that the deep learning algorithms which we can develop using PyTorch can also be developed using scikit-learn. But the advantage which PyTorch has is the GPU acceleration. It can scale the algorithm using GPU acceleration, which scikit-learn cannot do. And that is the reason we prefer PyTorch over any other library. So let's start the basics. So first we have to import PyTorch, which is in the name of torch, right? So once we have the torch, uh, we have to define in which device we would be storing the tensor of PyTorch. So like we have to like set the device to be used for the tensor. So just to explain tensor was simply it's kind of a matrix uh, which we have in mathematics, but matrix have a very defined number of elements and defined dimensions, but this tensor can have any dimensions depending on the nature of algorithms. So we will define device device equals torch dot device. Basically, uh, it should be CUDA if it is available. Otherwise, it should be yeah. So if CUDA is not available, then we will go ahead with CPU. So basically, what we are saying is either it can have a GPU, which is denoted by CUDA. Otherwise, the tensor would be stored in CPU, right? And let's create a temp, just a sample tensor to show how exactly we create tensor here. So yeah, so we have to just specify the different elements of the tensor, and then data type would be float 32. We can also keep it float 64, and device equals to device, which we have already defined. So let's print it my tensor. So these tensors, if you see, this is stored in a float. If we would have kept it integer here, like then it would be integer. So it depending float provides more flexibility in terms of the numerical computation. So usually float is more popular than int. Now let's create a sample algorithm using PyTorch. So what we will do is we will create a very basic deep learning network. So for that we have to import torch.neural network. Let's call it NN, and then we have to define new name of our multi-layer perceptron. So let's call it MLP. So MLP is a multi-level perceptron. Unit of uh, every unit of the layer is called perceptron, and when we have a multiple layer, it is multi-level perceptron. So we will call it my MLP, and it will inherit from inbuilt class which is nn dot module, and we will be defining here self uh, input size will be there, right? And once we have the, or we can just keep it constant for a while. Let's keep only self, and the layer which we will be creating, we will keep input layer at input layer with 784 neurons. So here we would be inheriting it from the NN module. So we will simply define and initialize this. And once we initialize, we will just create a new layer. So first will be, let's call it, it will be n dot linear. So what we are saying is the input, let's keep input as 784 and output as 128, right? So, and the second will be the hidden one. So hidden, let's call it 128, and the output should be 10. Let's call it 10 here. So this is a simply linear layer which in sequence the input will go through the FC1, and then whatever the output of FC1, it will go through FC2. So both are the linear output, right? So in neural network, if we keep only linear layer, then the output would be very much similar to linear regression. So to make the uh, change in the output, what we do is we apply a activation factor. So that activation can be anything but a linear. So usually we prefer ReLU. So ReLU is nothing, it's called rectified linear unit, right? So once we apply this ReLU, then whatever the output is we are getting. So this is uh, right now we are trying to have a sort of a classification. So what we are trying to do is let's take an example where the first layer would be having 784 and an image is passed through this layer, right? This first layer. Now what would happen is this uh, it, first layer will be having around 784 uh, neurons, and the output will be 128. Now this output 128 will again pass through the second layer with 128 neurons, and the final output will be 10. So this 10 output would be the number of, maybe we have the 10 different images of dogs, right? So these 10 images of dog will be determined using this neural network. So what would happen is once we get the 10 output, again it will go through ReLU, and this output, whatever we final output which we are getting, it will go through softmax. So basically softmax, it will create a soft. So in softmax, what would happen is for each of the 10 output, there would be a probability would be calculated for each of the 10 outputs, and maximum would be selected. So for example, if there are 10 different images of dogs, and a particular image has been through softmax, if it is getting a probability of maybe zero point 0.6, then it will be the final output. Only that value will be shown as the output value. So once we define it, let's also define the forward, and we will pass the input through it, right? So in first step, what we will do is we will pass the input to the first layer, right? So in when we initialize, these are all the methods which we have defined. And now using this method, what we will do is we will take an input and that input will be passed through each of these methods, right? So first what would happen is if X is an input, then X will sequentially, it's, so if, yeah, I think this input is already calculated here. Let's create a space and then I will explain it. Yeah. So the first layer is what we are doing is the input will go through the first layer. Now in second step, what is happening is the the output of first layer to the second layer. So X will first it will not be ReLU actually. Sorry, it will be FC2. And then once we have the FC2, then what we will do is we will pass the, instead of pass, let's write key apply ReLU activation. So for ReLU activation, what we are doing is X equals to L. So it is happening in sequence, right? This sequence is very important because first it will go through the first layer, then output will be this X will become the FC1X, and then uh, in the second layer X would become FC2X, and in final it will be ReLU X. And once we have the ReLU output, we have to create the softmax. So this value will be softmax. And once we have everything, so once we have everything, it will return the final value. So just to see what exactly we have created, let's create a new model using this class MLP. And once we initialize this, let's print my MLP. Let's save it and let's run. So you can see this model has been created. Now we can pass through, we can create the error, like what kind of error we are looking for, and then we can pass through the inputs and the outputs can be evaluated against the error, and then we can go through the training loop. So this was for today's video. Going ahead, we would tomorrow we will start with the evaluation part, and we will define what kind of loss we want to have in our model, and then we will create the training loop. So that was it for today's video. Thank you for watching.